All right, we're going to go over compound inequality notes. And before we do this, we're going to talk about interval notation. We did a little bit with interval notation last year, but I think we need a reminder. So when we're doing interval notation, whenever you see parentheses, this is also talking about open circles on the number line. It does not include the endpoints, does not include the endpoints. So write that in. Also, when we're dealing with going toward an infinite amount, when we're dealing with infinity, it also would include parentheses. Brackets are those filled or colored in circles on the number line, which means it does includes the endpoints. Endpoints are included when we're dealing with brackets. So going on to this, if I have the inequality x is greater than or equal to 2, on a number line it would look like this. I'm going to put 0 here, 1 and 2 here. And on a number line, 2 is included, so it would be closed. And it's greater than 2, so my arrow would be going that way. And how I would write this as interval notation, well, I know that 2 would be my left endpoint, or my smallest endpoint. My right endpoint, or my greatest number, is technically going to be positive infinity. And then my brackets, 2 is included, so I would do a bracket here. And whenever I have infinity, I'm always going to use the parentheses. So that's what my interval notation would look like. Let's go ahead and do the second one. X is greater than 2. On the number line, I'm going to put 0, 1, and 2 here. In this case, the circle would be open because 2 is not included. It has to be 2.1 or 2.2 or whatever. And my arrow is going this way because I have to have numbers bigger than that. And then for interval notation, my leftmost number, my smallest number, is still 2. And my rightmost number, or my biggest number, is still infinity. And how do I do my brackets? Well, 2 is not included, so I would use the parentheses. And with infinity, we always use parentheses. So that's what interval notation would look like for this. Let's go ahead and do the third one. X is in between 1 and 5. So on my number line, I'll put 0 here, 1, 2, 3, 4, 5, and I'll just add a 6 for fun. I know that it's going to be in between 0 and 5. I know that, 1 and 5. 1 is going to be open because 1 is not included. 5 is going to be colored in or closed because it is included. And I'm looking at all the values that lie in between. So anything bigger than 1, 2, 3, 4, any decimal or fraction in there as well, including 5. How would that look for interval notation? My leftmost or smallest number is 1. My rightmost or biggest is 5. 1 is not included, so it would be open. And 5 is included, so I would have that bracket. Let's go ahead and do this one. This one's going to look a little interesting. I have -3 and 4, so I'm going to put -3 here, -1, 0, 1, 2, 3, 4, and 5. So there's my number line. X has to be smaller than -3, so I'm going to have it an open circle because it's not included, and it has to be smaller, so my arrow is going over to the left. And then X has to be bigger or greater than 4, and that's going to be closed because it's included, and I want numbers that are bigger than 4. Ooh, so that's one kind of going like that. And how would I write that in interval notation? Well, I can't, because these numbers are diverging, they're going opposite, I can't make it into one interval notation like this. I'm going to have to use 2. So in this case, I'm going to describe this one first. My leftmost, or my smallest number for this arrow, is actually -infinity because it's going on forever in the negative direction. And my rightmost for this one is -3. And then For infinity, I always use the parentheses. And then for -3, 3 is open, it's not included, so I'm going to use that. So this notation is describing this arrow only. And then I'm going to write or because either of these cases are okay. Now I'm going to describe this arrow. So my smallest is 4. My largest is positive infinity. 4 is included, so it's a bracket. And infinity is always parentheses. All right, let's take a moment and go ahead and practice writing 1 through 12. I'll do numbers 1 and 7 with you, and then you practice and I'll just give you the answers. Let's see, I would like to write these as an inequality, so I want it to look like this. So -5 to 8. Well, that means -5. X has to be in between -5 and 8. It's bigger than -5. -5 is not included, but X is smaller than 8, but 8 is included, so it's like that. They have a little equal sign there. So that means X is in between -5 and 8. -5 is less than X is less than or equal to 8. And we'll do an example for number 7. I want to write the interval notation for this one. Well, let's see, I know that -2 is my smallest number, 3 is my biggest number, X is in between these numbers, 2 is not included, but 3 is included. So there's my interval notation for number 7. So go ahead and pause this video, and then I'll give you the answers to these ones. Here are your answers for these example problems, unless I made a dumb mistake, which is entirely possible. It is very easy to make silly mistakes with interval notation and inequalities. All right, let's go ahead and do a couple example problems. I'm going to do an example for number 1, and then you're going to do 2, 3, and 4. We want to solve the compound inequality. We want to graph it on the number line, and we want to write the interval notation. Oh my goodness, okay. So basically, to solve it, we're trying to say what value of X is going to make this inequality true, or this inequality true. Or means either one of them have to work. Both of them could work, but I only need one of them to work, at least one of them to work in order for this to work. Okay, so or, only one of them has to work. So what we're gonna do with or, it's really easy. I'm gonna solve this one, I'm gonna solve this one, and then I'm gonna see where they overlap, if they overlap at all. All right, so again, I'm just gonna solve this like normal. Add 3, I get 5x is greater than 10. Divide, I get x is greater than 2. Oh, well, that's nice. I'm going to go ahead and solve that, or graph it. If I put 0, 1, and 2, x is greater than 2 is going to look like that. So all of those numbers are going to make this inequality true. Let's check these ones. I'm going to add 6. Get 4x is less than -4. Divide, and I get 4x is less than -1. So I'm going to add -1. Open circle, x is less than that. That means it's smaller. All right, so any of these numbers right here is gonna make either of these equations true, which is, you know, what I want. So my interval notation, because this could work or this could work. I'm actually going to have two interval notations. I can't smush them into one. I'm actually going to write this down here because I can't fit it into the box. So this left one, I'm going to have negative infinity and up until -1. So all of those will work. Or I could have 2 up to positive infinity. Any of those will work. So this is my interval notation. Note that the only values that won't make either of these true are these ones in here. So if I were to substitute 0 in for either of these, 5 times 0 is 0. 0 minus 3 is -3. -3 is not bigger than 7, so it doesn't work for this one. 0. 4 times 0 minus 6 is -6. -6 is not less than -10. It's actually greater, so it doesn't work for this one. So these are the only values that don't make either of these true. I'm going to go ahead and do the rest of these because these are kind of example problems. This is a long video. That's okay. Number 2. Here, is that working? Okay. In this case, this is actually called a compound inequality. And the easiest way to do this is to actually separate these into 2 inequalities. So I'm going to separate this into this inequality here. 3 is less than 4p minus 5. And then I have a second inequality that I need to solve. I need to solve this one right here. 4p minus 5 is less than or equal to 15. And in order for this compound inequality to work, both of these have to work at the same time. So this is an and. So compound inequalities have an or they have an and. I'm going to solve both of these, and I'm going to see where they overlap. So I'm going to add 5. I get 8 is less than 4p. I'm going to divide by 4, and I get p is greater than 2. So I'm going to go ahead and solve this one before I graph them. Okay, so I have 2 to 5. I'll put 0, 1, 2, 3, 4, 5, 6, and 7. Let's see this one. P has to be, I could write it like this too. Oops, 2. P has to be greater than 2. So here's that one. All of these values bigger than 2 will make this inequality work. And P has to be less than or equal to 5. So here's 5, it's filled in, and I have to have all of these that are less than or equal to 5. Because this is an and, both of these arrows have to work. So I'm looking at where do these arrows overlap, and that is this section right here. That right there is where they overlap. If I write another arrow, like kind of do my final one, it would be from 2 up until 5, not including 2, but including 5. That is my final answer that makes both of these true at the same time. My interval notation would be 2 to 5, not included, included. So what this is saying that is I could choose 3, 4, or 5, or any decimal fraction in between, and if I plug it into here, this middle value will be bigger than 3 and less than or equal to 15. So that is an and problem. Where do they overlap? Let's do number 3 together as well. This is the same type of problem. I'm going to break it up into 2. So I'm going to have -9 is less than 3m plus 6. And I have to also solve for 3m plus 6 is less than or equal to 18. So again, here's my first one that I'm solving for, and here's my second one that I'm solving for. Let's go ahead and solve each one. Let's subtract 6. Divide by 3. Okay. Or if I wanted to, m is greater than -5. I'm going to solve my second one. Okay. So I have m is greater than -5, but m has to be less than or equal to 4. Okay. Where do those overlap? What values make both of these things true at the same time? Well, I'm going to go ahead and graph it on the number line. -5 is my smallest, so -5, 0, 1, 2, 3, 4, and 5. There's my number line. -5, I'm going to put this up here. It's open, and all of these values will make this inequality true. Now I'm going to graph this one. M has to be less than or equal to 4. That means it's closed, and less than is smaller. All of these values will work. Where do these overlap? That's my final answer. Well, it would be -5 all the way up to 4, including 4, and all of these middle values. These are the values that make this inequality true. Interval notation, -5 up to 4, not included, included. Let's do one more OR problem. You'll notice that the AND problems, the arrows are kind of going in between and you have to find where they overlap. The OR problems, generally the arrows are going out this way, like zoop. So this one's gonna be one of those zoops. It's already OR, so I'm just gonna solve this one and this one. F is less than -5. And then I have to divide by -9. Oh, remember, when we divide our variable, or if we divide the whole thing by a negative, we flip the sign. What was that? 5. Brain fart. All right, so I have -5 and 5. I'm going to write that into my... There we go. All right, F is less than or smaller than -5. So here's -5. It's not including, so it's open, and it's smaller than, so it's all of these numbers. And then this one, F is greater than or equal to, so filled, and 5. So all of these numbers. So this is my final answer. I'm looking for anything smaller or anything bigger. Any of these middle values will not make any of these true, which I don't like, but I just want to have at least one of them to be true. Both of them won't be true at the same time. It's not possible, but I can get one of them true. So my interval notation, because there's no overlap here, I have to actually have 2 intervals, and I'm going to write it down here because I could try to smush it, I suppose. My first one, I have -infinity, and it's going up to -5. Not including, not including, or, and then I have +5 up to +infinity. 5 is included, not included. So that would be my interval notation. So just a quick review, if you have an OR, your number line is going to look like whoop, like that, and you just have to get numbers that will make one of them true. If you have an AND, you're looking at arrows that are going to be overlapping generally, and you're looking for the area that makes both of the arrows true at the same time.